Hi everyone, I'm back again. A few days ago I tweeted out that I was working on this particular video, and I apologize for the delay, but it took me a lot longer than normal because I really went down a rabbit hole on this one. Actually, I think to this point, this is the most important video that I've done so far because it really points to a radical change in the automotive business. Now, in case you've missed it, Tesla released a new autopilot video a few days ago, and it's truly astounding. And I'll put a link to it down in the video description so you can watch it. But I will use parts of it later on in this segment to explain, what's really going on in the video. So what we're digging into today for this video started for me about 2 years ago when NVIDIA, the graphics card company, first showed their first generation of their Drive PX system at the CES show in January of 2015. Now, I had predicted last year during the Model X sightings in the spring that it would actually go into the Model X, but I was about a year and a half early on that prediction, but I was right. It did eventually happen. And at this year's CES show, they announced the second generation, which is the Drive PX2 system, which is about 4 times more powerful than the first one. So just a quick recap. What is Autopilot 2.0? This is the new system that's going into the Model S and the Model X. We're just going to call this Autopilot from now on just to keep things straight. So really it's 2 parts. There's hardware and software. So the hardware really comprises, it's 8 cameras. So 3 of the cameras are in the rear view mirror housing of the Model S and the Model X. There's 3 of them and they're pointing forward. There are 2 more built into the side markers. Those are the blinkers on the front of the car, and they're pointing backwards. There are 2 more cameras, and they're in the B pillars. Those are the pillars that hold up the side, where the doors close on each other. They're pointing forwards and a little bit sideways. And there's 1 more camera, and it's the rear view camera built into the trunk. Now, all of these cameras have up to a 250 meter range. That's 820 feet. There are also 12 long-range, new generation ultrasonic sensors, and they have an 8 meter or 26 foot range. And there's also a forward-facing radar in the camera that has LiDAR-like point cloud capabilities. And it has a range of 160 meters or about 525 feet. And then lastly, there's the NVIDIA Drive PX2 computer system, and it fits inside the box, about the size of a lunchbox in the trunk of the car. It's liquid cooled. So the cameras notwithstanding and the sensors notwithstanding, what is this NVIDIA Drive PX2 computer system? Well, in a nutshell, it's a deep learning, neural network, artificial intelligence computer purpose-built for autonomous cars. Now, in case you're freaking out, it's not Skynet. It's not going to become self-aware and kill us all. It's what we call narrow AI. It's purpose-built for a job. Now, I'll put a picture up here. The Drive PX2 is really a motherboard, and it has a variety of different input channels for sensors such as cameras, a LiDAR, ultrasonics, etc. It also has some output like gigabit Ethernet, CAN bus, which is a universal communications bus built into modern cars, and also an output for something called the NVIDIA Drive CX system. And we'll talk about that a little bit later in the video. It's quite important. So what are the specs on the Drive PX2? Well, for us computer guys, got some pretty serious chops. It has 2 Tegra 6-core CPUs with 8 gigabytes of memory, and they have about a 50 plus gigabit per second worth of bandwidth on this board. It also has 2 256-core Pascal GPUs, graphics processors, that can do up to 24 trillion deep learning operations per second at over 80 gigabits per second of bandwidth. Like I said, it's dead serious. I pulled a little paragraph from the NVIDIA website, and it basically says as follows. The NVIDIA Drive PX2 computer system is a scalable architecture available in a variety of configurations. These range from 1 passively cooled mobile processor operating at 10 watts to a multi-chip configuration with 2 mobile processors and 2 discrete GPUs delivering 24 trillion deep learning operations per second. Multiple Drive PX2 platforms can be used in parallel to enable fully autonomous driving. So some of us have grown up in the computer times when there's this war going on as far as CPU power and performance. So why are they talking about GPUs, graphics processing units, as opposed to CPUs? Well, in a nutshell, CPUs that are used in computers today are general purpose processing units, and they're hamstrung by backwards compatibility for general purpose operating systems, the Mac operating system or Linux or Windows for that matter. But GPUs, graphics processings, on the other hand, are not hampered by such constraints, and they're purpose-built to do massive parallel computings. And this is why we've seen such an incredible progress in the graphics power of computers, especially for things like games and science applications and movie CGI. So they're purpose-built for this kind of thing, and this is what NVIDIA is using in the Drive PX2 system. So you're probably asking, what the heck is a deep learning neural network anyways? Well, in recent times, this is the big buzzword that everybody's hopping onto. But I'm not really going to get into really crazy depth on this. But what it's a way of training computer systems to do pattern recognition and do it extremely quickly. The way it works is that you have a neural network, which is loosely modeled on the brain. And what it does is that it assigns weights. Sorry about that. It assigns weights to predicted elements as input, and then there are different neural layers inside of there that does all the heavy lifting calculations, and then the output is a probability, usually in a percentage. The higher the probability output, then the chances are that's the correct answer. That's kind of in a nutshell what it's done, how it works. Now, it's important in this modern age that they're using GPUs for this, because they're so much more powerful than a CPU, and this is why the Drive PX uses 2 of those GPUs in there. Now, some real-world examples that we use every day that you may not even realize it, of what a neural network or deep learning system are. Things like handwriting recognition, speech recognition like Google Now or the Siri system on the Apple phones, and things like image recognition that you would find on the Google Photo app, so you can type in the word cat or car and it finds everything literally instantaneously. So that's an example of deep learning. A lot of the social networks are using this. YouTube uses it if you happen to put some commercial music on a video and you upload it and they flag it instantly. That's deep learning neural networks detecting all that stuff. But the last example that I spoke about, which is image processing, is precisely what Tesla is doing with the Autopilot 2 system. So having said that, how does this whole thing work? What is it that makes it tick? Well, Tesla's latched on to NVIDIA here because they have basically pivoted the whole company to doing these autonomous drive systems as one of the new businesses that they're getting into. And they've developed a top-to-bottom stack. That's hardware, the software, the processes that are involved to make this a reality and happen. So the first part of this is NVIDIA's developed a supercomputer called a DGX-1, and it lives in a data center of sorts. And its basic job is to be trained through the neural network by giving it massive amounts of data sets, such as images and video, that includes various weather conditions like snow, rain, clear skies, fog, driving situations such as highways and urban environments with a little bit of steering wheel input, and that's critical too, that help the system accurately learn the environment and alter its behavior based on driver input, that's the steering wheel, to develop situational awareness. Now, the resulting model of this training is then downloaded over the air, as all Teslas are, to the Drive PX2 computer system equipped in all the cars in the Tesla fleet. That's of cars Model S and Model X, and of course Model 3, built since kind of November of this year. Now, I've watched several NVIDIA Drive PX demonstrations from CES with video footage given to the computers in real time, where the system not only detects road signs and lights, but also pedestrians, cyclists, obstructed pedestrians, as people that are in front of cars and you can't see them, or between cars, road hazards like little pylons, like the little construction pylons, construction signs. It can detect cars, trucks, SUVs, semi-trucks, motorcycles, and it can even see things like traffic speed cameras and cars braking well ahead of what you're driving just by looking at the lights on the car. It's truly astounding, and this is all done in real time. It's not a video that's put on the internet and processed after the fact. This stuff is actually detected. This is how powerful this system is. So with Tesla's fleet of Autopilot 2, which is the current Autopilot equipped cars, that the Drive PX system in there will also do the live detection and upload these classified objects. Now, I'm not talking about classifieds in terms of secret. What I'm talking about is that when the system detects objects and obstructions on the road and its environment, they're given classes. This is an SUV, this is a car, this is a motorcycle, etc. And because of the connected fleet, this information is uploaded to Tesla's massive data centers, and that can feed back into the DGX-1 supercomputer system, and it's a cycle, and the cycle repeats itself. So it's a live, in real-time learning system, and this has never been done on a car before. Nobody else has anything that's close like this, which is why I think the connectedness of the Teslas is so critical going forward. So by applying artificial intelligence to object recognition, such as different types of cars and pedestrians, streetlights, road signs, that the cars can do live path learning and planning, along with high precision and resolution maps, of course, and some GPS data, using the Drive PX computer system, along with this new Tesla Vision. This is kind of like what Tesla is actually calling their whole vision system, is that the cars will be able to accurately control the cars in an autonomous fashion and have a very high situational awareness that will increase safety by making safety decisions well in advance of what a human could. This is why Elon's been talking about orders of magnitude more safer than people. It's because the artificial intelligence system has more situational awareness than a human could ever have, and that's why it can do much faster and more accurate analysis of the environment and being able to do safer turns, safer stops, and this kind of stuff. Because I've talked about autopilot before, and there's a lot of discussion on what's going on, some of you have been asking about, well, how does autopilot to handle things like snow on the roads? Of course, I live in Canada. Sometimes you get snow on the roads. And I think the way this is going to work is because the system predicts road paths by using situational awareness from high-resolution maps, and it can actually see its surroundings just by using the cameras. Because the cameras are positioned in such a way that there's a certain amount of overlap, they can detect motion. And because it can calculate all of that stuff it can actually generate a 3D map of the world. It could see the road edges, it can see things like ditches, but it doesn't even need to see the line markings anymore. This is a very big difference between the first generation autopilot, where it had to see the lines on the road. This new system, lines on the road don't matter anymore, because it can literally see where the roads are at any given time and compute the path correctly. So I'm not here to claim that it's a perfect system, but I think this is why Tesla is actually putting the hardware in the cars today and releasing the artificial intelligence models over time, because they're using the current system and the software running in shadow mode, and they've actually confirmed this, to train the AI, the artificial intelligence, using real-world data gathered from the fleet instead of using a limited data set. So billions of miles driven on these cars in the real world should result in an artificial intelligence model running on the autopilot system that is way, way better than a human. So I think we're starting to get an idea here and starting to understand why Elon has been talking so much about artificial intelligence over the last year. I think their efforts with this new NVIDIA system has changed Tesla completely. I think it also explains why they've done the master plan part 2 with the fleet sharing, and why Elon also started OpenAI. So let's take a few minutes here and let's just go over this autopilot video really quickly. What you're seeing in this video is real-time object detection and classification from 3 of the onboard cameras. They don't have enough room to go, to show you all 8, but they've chosen 3 here. So the system is displaying bounding boxes in real time around everything that it detects, such as cars and some road signs, the street lights, as well as displaying the road in purple, even if it can't even see the lane markings. This is remarkable. Now, the video that Tesla put out is sped up quite a bit, so I'm going to try and slow this down and make it as smooth as possible so that you can see in real time what the car is actually doing, and I'll cut this up into different segments here. In the video, the car comes to stops at street signs and lights and successfully handles the turns, even with oncoming traffic and car merging. In a couple of places, the car stops for a couple seconds and tries to figure out what to do. The first stop that it does is when it detects the joggers and then slows down and then safely overtakes them. And in another spot, the car stops after making a right turn and then kind of carries on. So absolutely no driver input from either the steering wheel or the pedals are given to the car. This is all done in real time from an artificial intelligence model that was trained at head office, sent to the car, and the car does the detection in real time. You also notice at no point does the car exceed the posted speed limit. So I was able to spot 25 and 35 mile per hour signs on the roads here. All right, so the second part of this video. Now I mentioned at the start something about Drive CX, NVIDIA's Drive CX. Now what is this thing? So the Drive CX is a module which is basically a digital cockpit computer, and it's designed for the automotive industry specifically. Now it's capable of driving a total of 16.8 megapixels of display resolution and can render advanced graphics for up to 3 different displays. Are you starting to get a picture here? This little segment comes straight from the NVIDIA website. The system delivers the graphics performance required for 3D navigation rendering with realistic lighting effects, beautiful rendering of digital clusters, realistic rendering and compositing of a surround view based on multiple camera inputs, and enhancing video feeds from cameras to compensate for environmental conditions. Are you getting a little bit of a sense of what's going on here? That last little bit there. Compensate for environmental conditions. This plays in with autopilot. There's been a lot of talk on the internet, and even I have spoken about it too, is this concept of Tesla developing some kind of heads-up display. And I think the evidence for an augmented reality heads-up display has been staring us at the face all along. See, Tesla's already implemented this Drive PX2 into the Model S and the Model X, and they've confirmed it's going to be part of the Model 3. But the Drive CX component, and they haven't talked about this, but it's designed to work together with the system. It's designed to work to offer a next generation digital cockpit. And you'll remember Elon's tweet some time ago about the Model 3 control systems looking like a spaceship. And then someone else had asked, why the Spartan Dash? And he said it will all make sense at the final reveal. I think this is a direct reference to Tesla using the Drive CX graphics system to display Tesla vision to the driver in a modern way that will usher in the advent of the fully autonomous car. This is really important stuff. Now lastly, another little bit of evidence. Elon also made a comment at the Detroit Auto Show in 2015 when someone had asked him about the Model 3's design.
We're sort of having this debate of like how adventurous do we want to be with the Model 3? You know, the simplest thing to do would be to make it a smaller version of the Model S, but then we could also try to do something more radical. But I think we're going to try to do something more radical.
And he mentions about doing something radical. Now, some people will interpret this as referring to the exterior of the Model 3 design, but I think Elon is more big picture. And I actually think he was referring mostly to the systems design, interior control systems, and not necessarily the outside of the car. I think the basic evidence here, if you look at a Model 3, is it's a great looking car, but it's not a weird mobile by any stretch of the imagination. So I think his comment is really pointed at what they're going to do for the control systems of the car. And it explains a lot about how the simplistic design of the car going forward. Keep in mind, a digital dash is actually good to give the car long legs in terms of longevity, because let's face it, the Model 3 is not going to be redesigned for 6, 7, 8 years. So if you're in a position and the advent of the autonomous car is here, the technology exists today, it's real, why not design the car in such a way that takes more advantage of a digital dash so that the car feels fresh and it doesn't feel old and dated? I think a lot of this stuff really comes into play with the design of the Model 3. Now, another bit of evidence. I've been digging a lot into this HUD thing. Now, HUDs are not new. They've been around for a long, long time. But there is one company that's really pushing some of the boundaries here, and that's Continental Automotive. That's the company that makes the, the car tires. And they've been working on HUDs for years now. For many of the car manufacturers, such as BMW and Audi, Mercedes, note that these are all companies that, Tesla is going to be competing with their Model 3. And they've already shown augmented reality heads-up displays. Now, just so you know, there's two kinds of HUDs. There's something called a combiner HUD and a windshield HUD. Now, the combiner system uses a mirror to show the information. It's typically projected onto a clear sheet of plastic, and it's much smaller than a windshield HUD, which projects directly onto the windscreen. The windscreen type requires more space in the dash because the optics involved have to take into account the windshield curvature and correct for it. But the main benefit is that the projection is much further in front of the driver, somewhere in the vicinity of 1.5 to 2 meters. So there's compared to, say, like a combiner, which is only a few inches, like 2 feet away. So it's easier on the eyes. However, the windshield of the car also has to be coated specifically to prevent like inner glare of the car interfering with the HUD system. Tesla glass that they're talking about. Yeah, it's starting to come together, isn't it? Now, according to their website at Continental, that they were supposed to go into full production of augmented reality HUDs in early 2016. So that's already passed. I wonder who's going to be using those. Now, I want to make it very clear here that this is my opinion, but after reviewing NVIDIA's roadmap and how exactly it mirrors what Tesla's doing with their autopilot program, I really feel that this is the direction that they're going to make. Since the Model X and the X, due to the higher costs, will remain the technology leaders, it's entirely reasonable here that they will get the system before the Model 3. But keep in mind, they can't show this stuff and put it into the Model S and X without giving away the secret. So it won't be put into those cars until at least the Model 3 final reveal happens. Now, it could also coincide with a interior refresh of the vehicles as well. Or they may even wait and put that into a future version of the Model 3. So, but given that the Drive PX hardware is already into every Model 3, I think it could well be a standard feature. If not, could be an optional feature you have to buy. But as long as they indeed really do have the cost of the Model 3 in check, and the profit margins are enough to allow them to do that. So that's why you have to put that caveat in there. So even though I say this stuff, it may not make it to production. So I hope that this video really tries to explain really what autopilot means long-term as far as autonomy is concerned, and really goes a long ways to explaining some of these little subtle hints that Elon's been dropping, some of the hiring that they've been doing internally, and some of the technologies already available on the market. I think it's really going to come together in something truly exciting. I can't wait to the spring to see what they're going to pull out of this hat for autopilot Model 3 and going forward with this stuff. So anyways, thanks for watching. You can follow us on Twitter at Model 3 Owners. Don't forget to join our forum at model3ownersclub.com. And I always forget, but sometimes I have to put it out there, we have a Patreon page at patreon.com/Model 3 Owners Club. If you want to contribute to help keep these videos going and help us do the research and buy the equipment necessary for this stuff. So we appreciate all of our pledgers that are already involved, and encourage you to at least take a look at the page if you can. So anyways, that's it for today. Enjoy it. Don't forget to put the comments down, start talking about it. Exciting times. Thanks for watching.